I want to focus on the intent-based analytics. How do you use the same intent in the same product to actually operate your network and deal with service outages and problem management in general. My name is Rachamadugu, and I'm the head of Advanced Solutions Engineering at Apstra. So today I'll take you over a quick tour of existing tools and give you a demo. Full screen yes, sorry. Okay, cool. Yeah, so today I'll give you a quick overview of the existing tools and give a demo of intent-based analytics and then call for your action on how you can help the community at large. So if you look at the existing tools, there is a obsession, I would say, on visuals. Like you buy a new tool and it's, usually it has some kind of discovery feature that discovers all your devices, gets whatever telemetry is available, SNMP, CPU, memory statistics, and then graph the hell out of it. And it is very addictive actually, like you spend a lot of time, but at this, if you think about it, it is not the tool that was responsible for bringing up the network, nor is it the tool that you are going to use to change your network if you are actually using any tool to change in the first place. So the point being, it's a different tool with a different operational model, and that's why it has a hollow view of your network, and there is only so much you can do with it. And when it comes to customizability, there is not a lot of customizability. They collect a set of metrics and they give you a set of analytics, like in terms of thresholds and some sort of correlations. But if you want to build something new, like let's say you just had a service outage and you resolved it, usually you come out of it with a lot of learnings, like, okay, in this case, this is what happened. If we were to collect that telemetry and correlate it with this one, we would have detected it in the future. But how many times are you able to really teach a tool to automate that process so that you have it running live, real time and dynamically, so that you can stay ahead of the outages and on top of them once they are. And so if you take a look at the trends of like what's going on and how we can take advantage of the intent based and other things, like today the networks are becoming larger and larger thanks to the digitalization of the world. It's more and more devices, so that's why this screen based approach no longer works. Like if you have 100 devices and 20,000 interfaces, metrics of what interface are you going to monitor, how many screens do you need to really get a good picture of your network. And there is more and more telemetry data, like the devices, if you compare that with like 5 years back, the amount of telemetry available, not just SNMP, gRPC or APIs and JSONs and all of that, the amount of telemetry available is too much. And to make good use of it, you need to move to the standardized network design so that as a community we can agree upon what is a good design, and in that design what are the invariants that we can verify all the times to assess the true health of our network. And then usually when you have this much data, the natural tendency is to push all the data to some big data lake and use like machine learning, artificial intelligence, and wait for them to give you answers like overnight or over a week or whatever. But again, it's like so far away from your network and from the intent. Instead, if you analyze all the telemetry as it is appearing by taking advantage of the intent, you can get a much better insight and reduce your mean time to resolve all the problems that happen on the network. So I'm going to show you how to do that in the demo. And now let me introduce intent-based analytics of AOS. And here the emphasis is on the last phase. You have seen Carly and DJ already cover the design, build, deploy. When it comes to validate, AOS ships with a lot of built-in tests. But on top of that, you can use analytics feature to build new probes, as we call them. These are like data pipelines that capture these complex monitoring workflows so that you can have these insightful tests running real time on your network. And it's highly programmable, as I will show you. In fact, like creating a probe, you don't need any programming skills. It's a JSON payload that you post once, and once it's created, it's live and running always in sync with your intent and operational state. So the way I would like to summarize the operational model for IBA before I go to the demo is with this 3-letter acronym called C. You see the knowledge, not the raw telemetry. So the word C is like S is for select, enrich, and extract. So the first step is you want to select what telemetry you want to collect from what network elements. And to do this, you need to have a good enough model of your network. This is where it's really important for the product to be the same product that you use to build your network, because it is model driven building, and that same model you can use to select what network elements you are interested in order to ingest the telemetry from those elements corresponding to the problem that you are trying to automate detection of, or get more telemetry that is useful to reduce the resolution time. And enrich, this will be more clear in the demo, is since we have this intent, you can enrich the collected data with additional context. For example, in the demo I'm going to show you how we can ingest the statistics of an interface, and using the intent and operational state we can also get the list of affected VMs on that interface. And then last piece is why you are doing the first two pieces. This is where you are extracting the knowledge, and the knowledge can be in the form of anomalies that are much more deep and take advantage of the model. Like today, for example, there are monitoring tools. You either get a firestorm of events, alerts, or you get no alerts, and you kind of start to lose trust on them because there are so many alerts to go over. But here, the anomalies that you see from here are different because they are handpicked and they are very carefully handcrafted to avoid a lot of false positives. So what you see is usually a representation of a real problem.
Would you describe that as actionable items? In other words, if you get the first two steps right, the last thing you end up with are items that you care about and you're going to do something, you're going to take
Absolutely. And in fact, my colleague Ryan and Jera from ServiceNow will show you how you can automate taking action, because these anomalies are so specific. They are so specific that even the action is very obvious and it can be automated. So now let's jump to the demo, and I want to take the opportunity to introduce our CLI, AOS CLI, which is just like any other client for the REST APIs that we have. So I'm going to, for the demo scenario is like this, like your application guy came to you and said, okay, there is a database, my SQL servers are not performing well, there is a lot of drop packets, and they come to the network guy and say, we know the problem is in the network. They don't think it is, but they just know that the problem is the network for whatever reason, right? And so now your task is, okay, I have this fabric, imagine it has like 100 switches, and you are running vSphere underneath, and so each leaf has like whatever 30, 40 hypervisors, and you have first your problem is, okay, where are the SQL servers in my inventory, right? And can I do something about all the interfaces that carry the traffic of SQL servers, and then do some analytics on top of them so that I myself get a neutral view of any networking problems that are affecting these VMs. And to do that, we have probified the whole workflow that is relevant for this use case. And I'm going to create a probe, and then we'll go back to the UI to see the effect of this. So to create the probe, you basically create it in the context of a blueprint. And here I want to do something with the VM. So I'm going to collect all the error metrics available on interfaces that carry the traffic for SQL servers. So I'm trying to mention SQL here because that's what we are trying to dig deep into. And once you create that, it takes a couple of seconds, and we can go back to the AOS web UI that I've used. So here you can see the probe that got created. And before I go into the probe, let me give you a quick overview of the topology that I'm working with. It's a small topology with a couple of spines and couple of leaves. Each of those leaves is running a ESXi hypervisor that's managed by vCenter. And in this case, I have added the vCenter into the blueprint. And what AOS did is, AOS represents the intent as a graph inside our distributed data store. When you add a vCenter into the graph, we discover all the inventory, represent the vSphere inventory in the graph, and then correlate it to the underlay graph. So now after doing that, I know that this server that is on this leaf corresponds to a particular hypervisor in the vCenter, and I know what VMs are running in that hypervisor, and that's why I'm able to select only those leaves and those interfaces on those leaves that are carrying the traffic of SQL server VMs. So I'll show you how that shows up in the probes. by going to Analytics tab and clicking on the counter errors. So if you see the, this is, I am actually ingesting like alignment errors, FCS errors, joins, runs, discard packets, error packets, and you can see that one of the leaf on one of the interface is in fact, running the SQL servers. Like this leaf swap 3 is connected to a server which is hosting SQL VMs. So here you can see that this virtual machines is the point that I made. After you select, you are able to enrich the collected data with this additional context from the intent or from the operational state. So you have a immediate visibility into both virtual infrastructure and underlying infrastructure in one screen. So now I'm going to vCenter and I'm going to create a new VM. Okay. So this is the vCenter that I have, the US East pod. So I already have an existing VM. I'm just going to rename it to represent the creation of a new SQL Server VM.
Everybody see that and we can close concept.
So I have an existing VM. I'm creating. I'm just renaming it to be SQL, to just to save time on the demo. And we will see that once that is done, we can go back to the AOS, and in this probe, it should automatically detect the addition of a new SQL server by your vSphere admin. And there you go. So there is a second leaf that you saw now. This was the previous row, and now there is a second leaf which now started seeing a new SQL server. This is what we mean by its auto sync, both against the changes that happen in your infrastructure as well as for the changes that happen in your network. Like recently we were talking to a customer where he said, I have a maintenance operation, I am going to take this leaf out of maintenance, but I need to train my network operation guys to ignore like hundreds of alerts now, because I'm doing this change in one tool, but my monitoring tool is not aware of it, so it will keep generating alerts and we need to deal with ignoring them. But here in AOS, if you are taking, for example, leaf 1 or 2 into maintenance, you will do it with AOS, and this probe will automatically know that I don't have to monitor any interfaces on that leaf.
When, let's say, you are taking down one of the device for maintenance, and if the underlay is, let's say, BGP, in that case, will AOS push the, let's say, BGP graceful shutdown community to,
yes,
to the network?
Yeah, we have the concept of draining. So you can take the device into draining, and then that way gracefully
pushing necessary configuration.
Exactly, yes.
Right, to avoid any black holing.
Yep. So now I want to simulate like a anomaly and just show you that you can see the anomaly in the context basically. So for that, let me go to my AOS server and come back to my AOS. So here I have basically induced error packets into the network, and we should see the anomalies pop up here if demo guards are cooperating with me. Interesting. Oh, okay. Yep, so here you can see the errors. For example, in this case, there is a error packets. I expected like no error packets, but there are 600 error packets, and you can immediately see that it's going to affect not only the SQL servers but the web servers. And the error disappeared because it's a rate based thing, and you can always see the history by going to this guy, which shows you like there have been some errors in the past that were noticed on this interface. So here, as you can see, the focus, like we are not throwing hundreds of visuals at you. We are giving you an opportunity to carefully express yourself so that the tool does all the hard work, and what you need to see is just the knowledge, not a bunch of raw telemetry. So to summarize, like the benefits of IBA is it allows you to do streaming analytics in the context of IBM, and it's all declaratively specified. That whole probe that you saw, including every column in that UI, nothing is hard coded. It's all coming from a single JSON file that you post to a REST API, and once you post, it is real time and always in sync with your intent. And then any knowledge that you extract out of it, like as DJ showed, can be streamed out using Google protocol buffers. So again, if you want to really keep the raw telemetry, for archival or historical trends or whatever, you can use industry standard tools for that. We are more interested in focusing on the knowledge, not on raw data. And in terms of extensibility, like we ship with a lot of these probes and a lot of collectors that can collect different types of telemetry. But if obviously there is, as I said, there is like more and more telemetry available. If you come up with something that requires new telemetry to be collected, we have an SDK for any of you to develop the collectors, or you can always work with my team ASC, and we will work with you to automate these things and create new collectors as needed.
This is really a framework. I can do anything with this as long as there's a collector.
Yeah, absolutely. And the analytics, like as I said, each stage is like as data goes through the stages, you are basically applying different types of analysis to it. Yeah. Like things like thresholding, or sometimes you don't want to be alerted with a small noise, so you can say do it only if it is sustaining for a period of time. You can correlate, group by, standard deviation. We have about like 15 different types of analysis you can apply.
Are your customers typically the ones that are building out their own intent-based analytics on the platform? Are you working with them to build it for them to their specs? How does the engagement work?
So typically it depends on the nature of the customer. Like if they have DevOps people that are developers kind of thing, they are willing to do it. In fact, some customers are on the extreme of I want to create a new reference design myself, and we kind of help them with that. But typically large enterprises are like, okay, this is my spec. I trust you guys to know your platform best, and we have ASC engagement with them, and we do it. And when we do it, like all the probes that you see in the GitHub here are in fact like most of them are a result of us working with large enterprise customers, and we have SLAs in place so that what we produce is not specific to them, it's generalized. And that is where I wanted to actually call for your action. You guys are the industry recognized networking experts. And if you have any thoughts, please share them on the GitHub, and we'll be happy to expand on this catalog to benefit the community at large.
Can you open the earlier slide?
Sorry?
Earlier one, just not this one. There was another one. Yeah, this one. It says, for example, MLAC or ECMP imbalance. I think we are talking here mice and elephant flows, let's say.
Yes.
And some interfaces are congested and others are not utilized.
Yes.
So in this case, okay, analytics are warning us, but is there any action, and how Apstra is helping to make it balanced?
Yeah, that is what I will leave to Ryan, because that's the subject of the demo. I don't want to spoil the, Okay. Yeah, and also like these are just some examples to give you the power of what you can do. For example, in case of vSphere, usually the vSphere admin has an expectation on certain VLANs to be trunked on the underlay. So usually they open a ticket or something, and there is a chance that he's expecting some VLANs, but Leaf is not trunked on all the VLANs.
Usually they ask, okay, enable everything, please.
Yeah, which we don't want to do.
Yes.
So there is a probe actually that can take advantage of all the holistic model we have, and it can automatically detect any mismatches on the VLANs. And imbalance and hot cold interfaces, you can do a lot of very, very insightful things. I mean, these are things that are unheard of. Forget about automating them. GitHub, you want to open? Yeah. Yep, so this is the GitHub, and you can see, these are all the probes, and we constantly add them, like we refresh them regularly as we make improvements on it.
Those probes that you're pulling telemetry elements off the local fabric.
Yes.
Things that, okay.
Yep.
So what about probes such as, I want to see latency across a link, something like that?
Yes, we do have one which is monitor packet loss. That is actually doing active pings on a specified IP, and then ingesting that telemetry into you.
So sort of an SLA measurement. that
Exactly.
kind of thing.
Yep.
Yeah.
Yep.
Okay.
Yeah, a lot of things are possible with this because the collectors are extensible, so you don't need to really collect anything. You can do some tests also. Like sometimes some customers come to me and said, okay, I have this rendezvous point, Anycast peer and all that. Anycast DNS, can you constantly do that so that I want to know when it's up, when it's down?
Yeah, as soon as you can do that, some of the possibilities get very interesting, especially if you've got specific application SLAs you're trying to conform to.
Yep.
To be able to isolate where the problem is using that is really powerful.
Yep, absolutely.
And I believe you can export all the objects into some kind of Grafana apps.
Yes, yeah, absolutely. So any stage output you have seen, there is a checkbox that says enable streaming. Once you do that, it's streamed over Google Protocol buffers to an external endpoint that can do anything with it.